Hello, grade 5 math students. This is chapter 4.1, Multiplying Proper Fractions. Let's begin by using models to multiply fractions. Let's say that our friend Margie drew a rectangle and colored 2/3 of it blue. And here is Margie's rectangle. She then drew stripes over 1/2 of the colored parts. So we'll take what we have here and divide it in half and draw stripes over half. So over what portion did she draw stripes? Well, what we want to calculate here is 1/2 of 2/3. Whenever you hear the word of in math, it's code for multiply. So 1/2 of 2/3 would be written like this. 1/2 of, or multiply, 2/3. So we would calculate the amount of the rectangle colored in by multiplying 1/2 times 2/3. To solve Margie's problem, we'll simply count. How many parts have stripes? 1, 2. And how many parts do we have total? 1, 2, 3, 4, 5, 6. So 2/6, or in simplest form, 1/3. 1/3 of Margie's rectangle has stripes. Now let's say that our friend Paul draws an identical rectangle and colors half of it blue. And here is Paul's rectangle. He then is going to draw stripes over 2/3 of the colored part. So we're going to divide the rectangle into 3 equal parts. And Paul's going to draw stripes over 2 of those blue thirds. Okay, so now we want to know how many parts of Paul's rectangle have stripes. Well, in this case, we're finding 2/3 of 1/2, or 2/3 times 1/2. When we count our parts, we have 1, 2 with stripes. 1, 2, 3, 4, 5, 6 total. That becomes our denominator, or 1/3. So just like Margie's rectangle, 1/3 of Paul's has stripes. What I want you to notice here is that though Margie calculated 1/2 of 2/3, and Paul calculated 2/3 of 1/2, we got the same answer, didn't we? 1/3. Please notice that when we multiply fractions, order won't matter. Let's go on to the next idea. Now let's multiply fractions without using models. Let's find the product of 3/4 and 8/9. There are 2 possible methods for multiplying fractions. The first method works like this. We'll take both numbers in the numerators, 3 and 8, and multiply them by one another. Then we take the 2 numbers of the denominator, 4 and 9, and multiply those by one another, giving us a new fraction of 24/36. In order to answer this correctly, we need to reduce 24/36 to its simplest form. Each of these numbers is divisible by 12, so this fraction at its simplest form will be 2/3. Now let me show you method 2. In method 2, for 3 times 4, or 3/4, times 8/9, we're going to begin by looking for a common factor. This numerator, 3, and this denominator, 9, share a common factor. It's 3. So we're going to begin our problem by taking 3 divided by 3 over 4 times 8 over 9 divided by 3, giving us new fractions of 1/4 times 8/3. Now let's examine our other pair of numerator and denominator, 8 and 4. These are each divisible by the number 4. So we're going to write another problem here. It'll look like this, 1 over 4 divided by 4 times 8 divided by 4 over 3, giving us a new pair of fractions, 1 over 1 times 2 over 3. Now we complete this problem by multiplying across. Numerator times numerator gives us 2. Denominator times denominator gives us 3. What we've just done is a process called cross-dividing or cross-reducing. It helps make the fractions a little bit easier to work with by making smaller numbers. It probably looks pretty complicated right now, but after we practice it a few times, you'll see that it can actually be quite a bit easier as you work with larger numbers down the road. Let's try a few more problems like this together, just to give you a better feel for how method 1 and method 2 each work. So let's try 1/3 times 6/7. Method 1 has us take 1 times 6 to get 6, and 3 times 7 to get 21 for our denominator. Now we need to reduce 6/21. Each is divisible by 3, correct? So we're going to divide each by 3 and get a final answer of 2/7. So 1/3 times 6/7 is 2/7. Now let's use method 2, 1/3 times 6/7. This time I'm going to look for common multiples that I can use to reduce the fraction before I begin. All I'm doing is changing the order in which I complete this process. In method 1, I multiply first, then divide to reduce. In method 2, I divide to reduce first, then multiply. So I need to look at our pairs of numerators and denominators that are across from one another. So I'm going to look at numerator 1 and denominator 2. Do they share a common factor? Sure, but it's 1. So it doesn't really do us any good to divide each by 1. We're going to come up with the same answer. So now I want to look at the other pair. Numerator 6, denominator 3. Now each of these can be reduced by 3. They're both divisible by 3. So I'm going to divide 3 by 3, and I'm going to divide 6 by 3. And now I'm going to rewrite my fractions. I have 1 over 3 divided by 3 gives me 1, times 6 divided by 3 gives me 2, over 7. Multiply across, and I get 2/7 for my answer. See, you get the exact same thing. You're just doing the processes in an opposite order. I like to use method 2 simply because I find it easier when the numbers get larger. I don't like to multiply big numbers. I would rather divide first and then multiply by smaller numbers. But you do whatever works best for your brain. If you like multiplying big numbers, cool. Use method 1 and then divide when you're finished. Let's try a couple more of these together. Our next problem is 6/8 times 4/9. Using method 1, we'll multiply our numerators first. 6 times 4 is 24. Next, we'll multiply our denominators. 8 times 9 is 72. Now, we reduce. I'm going to use mental math to do this. If I know that 75 divided by 3 is 25, then I know that 72 divided by 24 is also 3. So my answer is 1/3, because I can divide both numerator and denominator by 24. Now let's try method 2. 6/8 times 4/9. Let's look at our first numerator and denominator pair. Do these share a common factor? They sure do. 3. So we'll divide each by 3, giving us new fractions, 2 over 8 times 4 over 3. Now let's look at our second pair, 4 and 8. These are each divisible by 4, right? So let's rewrite our fractions again. 2 over 2 times 1 over 3. Now we multiply across, giving us 2 over 6, or 1/3. Once again, it doesn't matter which way you do it, as long as you understand what you're doing and you can show me your thinking. So if you prefer to multiply and get large numbers, and then work with that, great. If you prefer to reduce and then work with smaller numbers when you're multiplying, do that first. Totally up to you. Let's work through one last problem together. 10/15 times 3/4. Following method 1, numerator times numerator, 10 times 3 gives us 30. And denominator times denominator, 15 times 4 gives us 60. This reduces to 1/2. Each is divisible by 30. Let's try method 2. Let's compare our first set of numerator and denominator, 10 and 4. Each is divisible by 2. So let's divide both 10 and 4 by 2, giving us new fractions of 5/15 times 3/2. Now let's compare our second set of numerator and denominator, 3 and 15. Each is divisible by 3. So let's divide to create our new fractions, which will be 5/5 times 1/2. Now here we can do one of two things. We can either multiply across, giving us 5/10, or 1/2, or we can say, we know 5 over 5 is 1. We can just make that a 1 and know that our final answer is 1/2. Once again, whichever order you do it in is okay. It's basically the same process. Now practice this idea on your own. Find the product for each problem in simplest form. You may either use models or you may simply multiply. If you can, try using that cross-reducing. That is, finding the common factors of an opposite numerator and denominator to simplify the problem. Believe it or not, folks, that is the end of Chapter 4.1. I'll see you tomorrow to work on some word problems using multiplication of proper fractions. See you then.